So now we're going to identify the objects. We're going to threshold them out and pick out these nuclei. We've done a quick process. You could have done a smooth or a few other things to get rid of some of the noise and clean things up some. So I'm going to close that window now and then turn off the eye here so we don't see that again when we run through the process. Let's add the object processing. So objects are the main things we deal with in CellProfiler. They're the regions of interest that we want to play with and identify the individual cells and puncture and anything else within or outside. And we have primary, secondary and tertiary. So these are the three main ones I will be using. Primary are objects that are just on their own from the start, unrelated to anything else. Secondary are based from the primary, and again tertiary are based with secondary and primary involved. So you can have a combination of different objects and looking within just those or just inside those, and these can be very useful. I've used primary and secondary a lot, tertiary not so much. So let's add a primary object, and it's got a lot of options, and every time you change some of these options, some of the options below will then change. So this is going to be a long one, and this is one of the steepest parts of a learning curve, but one of the most important. Let's bring in our nuclear morph. We could decide we don't want it and just bring in the original, but let's do the nuclear morph, and we're going to call that nuclear object. I like to name it object so I know which one I'm talking about. We have typical diameter objects. We can discard outside the diameter range. We can discard those touching the edge. And then we have a very complicated and subtle set of different parameters in the threshold strategy here. Automatic sometimes works. I rarely use the automatic, and I generally go with either global or adaptive. There are cases where the per object work. Manual is something we kind of want to avoid. We don't want to have a manual threshold. We want to let the statistics and the power of these different automatic strategies find the edges and find the structures for us when the data varies a little bit, and it can help keep it more consistent to use the auto method. So let's go with something like global, for example. And global is across the entire image. It has the same threshold, and you can do an adaptive threshold which varies if you have a background which changes. In our case the background is pretty consistent, so global will be fine. And then within that method you can do a bunch of different in a strategy you can do a bunch of different methods and a bunch of different options to read up on. And if you're in a rush, you can just look at the thumbs up and see where this particular method is good for this and not good for that, etc. I will often forget which ones I've used in the past, but mostly Otsu, mixture of Gaussian and robust background. Those ones are most common, but when you read them, you'll find it might be more applicable to your data sets. And it doesn't hurt to just empirically check them and see how they look and see if they jump on the data a little quicker. And knowing how to go with this can be a little empirical. It's good just to do a test mode and step. So let's step on the first one. It doesn't give us an output, and then we're going to step on the next one on the identified primary objects and see what it gives us. So let's open up our window a bit bigger here and see how much we can see at the same time. Okay. Right, so it's found them, but it's found two small segments, so we're not quite sure we got the size right here. And note that CellProfiler deals with things in pixel units. So we've got a measure tool up here. We can click on, bring it back in, tools, measure length. And you can click on one end, click on the other end. And I can't move my mouse, but down the bottom right of the corner of this window there's a 97 length there, just to give us a kind of length across the image. So we're dealing with objects, the typical diameter objects. I think we're going to say somewhere between, let's say, I don't know, maybe 60 to 120. And how you set this range depends how well it finds things, whether it breaks it up more in different places. And if we do step again, you can see it's found a much better job of the images there. It's brought in this kind of this extra staining from the nuclei or the DAPI staining around here, which is not so great. So we'll see if we can do something about that with the settings. One thing I like about that Otsu method is it has different ways of looking at the histogram and splits it into 2 classes or 3 classes. If you go for 3 classes, you can take the middle section of the histogram and it'll find the low numbers and the high numbers and then the mid numbers, and you can tell it whether it's going to be foreground or background. And that's often a good one to play with, just to see which way is going to give you a better breakdown on the cells. And that helped a little bit to throw that that third class, potentially this part here might be in a third class, into the background. And that's one way to do it. Another way I often use is this threshold correction factor. If you let the automatic system find a threshold for you on your image, you can then say, okay, that you automatically find it, but then we're going to times it by a factor of 2, for example, and that will bring the threshold higher, and it will tighten up the perimeter, the green perimeter you see here around the edge, and bring it higher up the intensity gradient here. So let's try 2, and that brings it in a little higher, and it does a slightly better job. So I'm going to be happy with that. And how you do this will obviously change the size very subtly, depending on the data sets. So bear in mind that this is going to change things a little bit, and you want to try it on the good ones, the bad ones, the medium ones, and see if it grabs the edge, and look at the green part to see if you're happy with where it's found that boundary. And that's the basics of finding the outside of a nuclear object. I'll do a more complicated, more in-depth one at some point in the future.